Yo! Hopefully you can hear me. What is up, guys? How are we going? Hope everyone is doing well. Oh, I've forgotten to do one thing. Let me do this. I gotta find my calculator application. How's everyone going? Welcome back to Nutshell Maths on a Monday. Hamza's here in the chat. Thank goodness. There we go. We got the calculator ready. Yeah, I agree with Mr. Maraji. You guys do well in calculus. That's the pay rise right there. Everyone going well? We have, quite possibly, the hardest thing you will learn so far this year. Or the hardest thing you will have covered so far this year. I reckon anyway. It's not crazy complex, but it's kind of a bringing together of multiple different things. Okay, so today's lesson might be a little bit longer than normal, but that's fine. And we might even spend some more time on this tomorrow as well, which means we'll push our extra stream one more day. Okay, can everyone hear me all good? Everything's all good? And if we're good to go, let's get into it a little bit. Daishok size happy, everyone's all good. Say hello if you're in the chat. Let's go. Right, I just want to recap very briefly on what we finished on last time, right? It's been the weekend. Hopefully you guys got to at least go for a walk or something. But look, on Friday we did multiplication of polar form, and we finished by Miss Maraji forcing me to go into a couple of these sort of questions here. And I'm just going to do maybe the first one, or maybe the first two, if I really feel like it. But I just want to very briefly recap this. Right? The idea is that if we have a complex number in polar form, doing powers of that number is really, really easy. Okay? So if we look at this first question, 2 cis pi by 6, all to the power of 5, and we want it in rectangular form. Okay, I'll do example 1 and example 3. Okay? Then this can turn into quite easily, we go 2 to the 5, cis, and we multiply the angle, 5 pi by 6. Okay? 2 to the 5, if we go to our calculator, 2 to the power of 5 is 32. And we can leave 5 pi by 6 as it is. And we're happy, right? It does say put it in rectangular form, so we can quickly do this conversion, right? Where we write it out in full. The full definition of this is 32 cos 5 pi by 6 plus I 32 sine 5 pi by 6. Alrighty. And if we type in those pieces, what I got to do is make sure my calculator is in radians for this. Anytime you have pi in your angle, always just double check you're in radians. Otherwise your cos of your angle is going to be really weird. Cos 5 pi by 6, we get this, minus 27.71 plus, well, I'm just assuming plus, but it might not be plus, 32 sine 5 pi by 6. It is plus 16i. And that's our answer. Right, Kate's here as well. Good. Right, example 2 is almost identical, so we're not going to do that. It's not possible to make our calculator bigger. Sorry, Mr. Maraji, look, if I make it bigger, that's it. It's literally impossible. This is the worst software in the world. But it's free, or maybe I torrented it? I don't know. That's as good as I can do. Sorry, man. Right, let's do example 3. It'll take a little bit more time, but let's do example 3. And go from there. So example 3, I'm going to post all the answers to these questions on Google Classroom anyway. Raises the names. It makes everything go faster, doesn't it? 1 over root 2 plus 1 over root 2i all to the 12. Now, when it says here, calculate the exact value, I phone called Mr. Maraji and we had a conversation about this sort of stuff. And exact value typically means that this answer to this is going to come out as either just a real number or just an imaginary number, right? So that's just like a little bit of direction, I guess. But essentially, we still know we've got a complex number to a big power. We're not going to write out 12 sets of brackets. We're going to use our de Moivre's theorem and do this ourselves, right? We know we can do that. We should be thinking that already when we see this question, right? I'm just going to move all of this down onto this page because this question takes a bit of page. Cut. And let's go down here. Right. So, someone in the chat said change to polar form. Of course, right? That's our first step because we can only do de Moivre's theorem in polar form. That's the beauty of polar form. So let's go like this. 1 over root 2 plus 1 over root 2i. Let's change this to r cis theta. Okay? R is quite obviously going to be the square root of the first one squared. 1 over root 2 squared plus the last one squared. 1 over, this is getting a bit small. Let me do it underwards. R equals the square root of 1 over root 2 all squared plus 1 over root 2 all squared. Yeah, underwards. That didn't make sense, did it? Right. It's Monday. It's Monday. You could probably figure this out. Right? We can be a little bit clever. This is 1 over root 2 times 1 over root 2 is just root 2 times root 2, which is 2 on the bottom, right? A half plus a half, which we can see as the square root of 1, which is just 1. Okay, if you really want to, you could type that into your calculator and get the right answer, but sometimes we can just be a little bit clever. Okay, Kate's already done it. Right. Hamza's asking us to wait. Ask your question, Hamza. Oh Lord. Hamza, type it into your calculator. Half a cake plus half a cake is how much of a cake? Goodness gracious. Right. So we've got, let's do the theta part now. If you want to, you can draw the diagram. I would recommend it. But we should start realizing that when both of these are real, when both of these are real and positive, we know that it's just going to end up here, right? Which is 45. So it's going to be 45 degrees. So I can write my r cis theta now equals 1 cis 45. If you want to do radians, you can do pi by 4. Okay? Good. Now we're going to do 1 cis. Now we can actually answer the question. All of this to the 12, which is going to be 1 to the 12, which is 1 cis 12 times 45. 12 times 45 is 540. Now, I think technically you could leave it like this, but it's really, really bad practice, right? We don't like to do that. Oh, Kate just got timed out. What'd you do, Kate? Right. So, it's really bad practice to leave it like this. So we need to think like this. If you imagine, I spin 540 degrees. I do 360 and I end up back here. And I'll do whatever's left over after 360. We'll keep going around here. So if I do 540 minus 360, you can see I'll do a whole nother 180. Okay? So that means I have 1 cis 180. And this concept is important to understand, right? That one rotation and then we keep going another rotation. This concept is really important to understand for the next section. Everyone happy with that? Mr. Maraja, you happy? I don't want to do any more of these because I want to move on to past this. But example 1, example 3 done. The other, I think example 3 might be the hardest one. Looking at my notes, it's the longest one anyway. It took me the longest amount of working, so it should be pretty easy. This chat is better. Yeah, I've got like the Nightbot on like super high moderation because I don't trust you guys. Right, now this is where we're gonna separate the kids from the adults. Okay, the year 12 algebra to the calc students. Right. Let's have a look at this. Right. I want us to focus. I want us to listen. Right. And think about this. Oh, I see what you're saying. Oh, so. Yeah, this isn't finished. This isn't finished. I didn't finish the question. Mr. Murray is saying go further. Yeah, once this 180, this here. Remember, I said at the start, it says exact value, right? Exact value of this, and we should be ending up with a real part or an imaginary part. So I didn't go any further. I'm silly. I forgot. Right? So if we go back to this question very quickly, think about it in terms of a plus bi. There's a couple ways you could do this, right? Remember, you could write the exact value as 1 cos 180 plus I sine 180, right? So we're going to go 1 cos 180 plus I 1. You don't really need the 1 sine 180. Or you could draw a diagram and think about it, but this is always your safe bet, right? Or am I in degrees or radians? So I'm in radians, so let's make sure I'm in degrees. Cos 180 is minus 1 plus I times sine 180 is 0. I times 0, therefore just equals minus 1 is the exact value. Sorry, I didn't finish. Okay. Vash, good question, right? We've just got there. There's the exact value there. This is your holidays. It's also my holidays, Cape. So we're all working during the holidays. Relax. Yeah, no holiday for Calc. Calc never takes a holiday. Right, are we happy with that one now? There we go. Mr. Murray is happy. That's better. Sorry, it's Monday. We're a bit sleepy. Okay, and I'm really excited for the next section. That's actually what it was. I was just like, I've got my notes here. Look, I've got notes on notes on notes on notes. That's what we're doing today. I've got 5 pages of notes. Whew! I'm excited. Right, this is what's going to separate the men from the mouse, right? I've skipped the whole page because I want to start afresh. Oh no! It stopped working. Why did that stop? Give me a second. Let me do this. Yeah, I have to reconnect my iPad. There we go. Right. Whew. Let's do it. Okay. So, I want to bring together some things we've got. The first thing I want to bring to the front of our memory. Yeah, I agree with Mr. Maraji. Really focus on this, right? Is de Moivre's theorem, right? Which is what we just did. De Moivre's theorem. I've even got some notes here, right? But I might just come back to these as I'll flick back to these. Which we know that r cis theta, all to the power of some number, let's say n, equals r to the n cis n theta. We know this, we've done it, we're good. Right? The second sort of fact, let's bring together some facts, right? Kate loves facts. So the first fact is that we know this. The second thing is, through some logic, we could extrapolate this, right? That if I had a special case of n being a fraction, let's say a half, in the above theory, right, in the de Moivre's theorem, well, this would turn into what? We could say r cis theta all to the half would be r to the half cis half theta. Exactly the same. We're happy. And it would work with any fraction, where a fraction is actually a square root, right? A fraction is actually a square root. So I could even say, therefore, I'm not going to worry about that. I just want you to think about that. Okay? But to the power of a half is actually a square root. Right? To the power of a third would be a third root. Okay. The third thing I want us to think about is, if I told you that z squared equals 4, where z is just any unknown, I'm not saying whether it's complex or imaginary or anything, to find the unknown, you would take the square root of 4. But what am I missing here? Right? That we've done over and over again this year. When I take the square root of this, what am I missing? I'll wait, because I want to make sure you guys are paying attention. Tina's onto it. A plus and minus, right? Tina's probably got the best internet. Plus or minus, right? Good. So we're missing the plus or minus, which implies that there's two answers. Okay? And in fact, there's a thing called the fundamental theorem of algebra, which means that if I had, I'm just going to write it here, but I'll delete it, but I just want you to know, if I have z to the 3 equals 4, then it's not necessarily plus or minus, but we're going to have 3 answers. And if I have z to the 4 equals 4, I have to have 4 answers, right? And we kind of know this, right? We know this from looking at quadratics, x3 plus x squared plus x plus 1. We know that this turns into 3 brackets. We know this, right? Which is the fundamental theorem of algebra. The highest degree is the number of solutions. Now let's combine these 3 thoughts together to solve one single problem, right? And here's my notes here for a second. Right? So we've got de Moivre's theorem. We've got de Moivre's theorem if we used a fraction, exactly the same. We also know that the opposite of squaring is square rooting, and we always get 2 answers. So if you imagine this scenario here, but instead of z squared equals 4, we said z squared equals 16 cis 30, then the square root of 16 cis 30 must have 2 solutions, right? The square root of 16 cis 30 must have 2 solutions, because this is true. What we've just said here is true. Are you with me? Please tell me if you're with me. Kate's screaming facts. Right? We're kinda with me. Just stay focused. Just trust me on this. Right? If z squared equals 4, this we know that it produces 2 answers. If z squared equals some complex number, we know we're going to have 2 answers. It's the same logic. Right? It's this exact same logic. So let's follow this through a little bit. Right? Where if I said this, so therefore to undo the square, I'm going to square root the other side. Like this. And I follow this through using the de Moivre's theorem we just talked about, where this becomes the square root of 16, which is 4, cis, and we're going to times 30 by a half, 15. Right? But the problem here is we must have 2 answers. We must have 2 answers here. Right? That's the fundamental theorem of algebra. We must have two answers. So let's think back a little bit, right? Kate's kind of guessing, which I don't mind, but it's not quite right. And your guesses kind of make sense, right? Where you have plus or minus because we're square rooting. But it doesn't work like that. And let me bring in like the fourth little fact for us. Okay? And we're going to combine these four pieces of knowledge to then answer this question. So the fourth piece of information is, if I have some complex number, this angle, let's use the angle from above, was 30. Right? And my R is, what, 16. Would you also agree with me? So this, I'm saying that Z equals 16 cis 30. Would you also agree with me that Z could be written as 16 cis 390? Do you agree with this? Right, I'm liking the confusion in the chat. Right? Yeah, I'll just zoom in for a second. Would you agree with this? That these two things are the same thing? Because if I went 390 degrees, I will do 360, and then I'll do another 30. And my angle is exactly the same, the radius is the same, so I end up straight back there. You with me? And then you could even go one more. You could also say, oh, Z is equal to 16 cis. Let's go like this. I'm going to make it 30 plus 360 plus another 360. Hannah's exactly right. Or 16 cis minus 330. You with me? And you could do this an infinite number of times in both directions. You could circle counterclockwise and go positive. So you could circle that way that we've got on the diagram. Or you could circle the other way, what Hannah's saying, negative, forever and ever and ever. And each loop you do is the same number. Right? So we've got these four facts now. We know this piece of information and we know the rest. So if we know this fact 4, what we can say is, if Z equals 16 cis 30, then Z must also equal 16 cis 30 plus 360 n, where n is just going to be some number of loops. And Miss Murray is exactly right. This is what we did in the last question, where we had 540, and we looped a little bit further, and it became 180. Which is, when I said there, I said this is important for the next part. Right? So are you happy that these two Z's here that I've written are exactly the same, where n just represents how many loops we do? And if n is positive, we're going to go in this direction. And if n was negative, we'll go in Hannah's direction. Right? We're happy. It's Z. It's Z. It's Z to Z. So if we go back to this question, right? Or I've got the question on the left here, example 1. You see that? Let's start it again and use these 4 bits of knowledge. This is why this is the hardest thing you've done so far, because you have to combine like 4 theories together to nail it. And it's all theories that we've kind of just learnt. So let's look back at example 1. So the question, Z squared equals 16 cis 30. Remember, the problem is we have to have 2 answers. Right? That's part of the problem of this. So let's say, I could also just say Z squared equals, if this is some complex number, then using our knowledge that we've just explored, I could say this, where n represents how many number of loops I'm going to make. Right? This is my first step. I say, well, if 16 cis 30 is true, then so is 16 cis 30 plus an infinite number of 360 degree rotations. Yeah, theta mode's great. Highly recommend theta mode. So we're happy with this. Now let's use fact number, I'm about to sneeze, 2 here. I'm going to sneeze again. No, I'm not. We're good. Right, we're back. Or, you know when you feel like you're about to sneeze, but then you're not going to sneeze, but then you are going to sneeze? Right, let's use this other fact here to now work through this question. Thanks for the blessings, team. So now z equals, I'm going to go nice and slow, all to the power of a half. You happy with that? And now we can work through this problem. Well, this 16 becomes a 4 like we had before. And this piece becomes 15 plus the, we're going to half it, right? Because we times this piece. 360 times a half is 180. Like this. Tell me if you're confused here. And now we've got a clever way to produce multiple answers, right? And that multiple answers depends on n, our loops. So let's have a look at this. Okay, let's make this condition first, n equals 0, which is our default case. It always is true. When n equals 0, our z would be 4 cis. Krishna, I like the question. I will answer that shortly. Plus 180 times 0, right? So this is just going to be 4 cis 15. Okay. It's not a square root, remember? De Moivre's theorem. We got lost. Okay, remember De Moivre's theorem here. When you're square rooting the whole thing, we square root the front and we times the back. Okay. Then I'm going to substitute in n 0. And what I might also do is say, well, if n is 1, if I'm doing one positive loop, let's see what happens. Z equals 4 cis 15 plus 180. Z equals 4 cis 195. And we don't like to write 195 because that's more than 180. So if you think about it, 195 is the same thing. You could think about it like this. 195 is going over by 15 degrees, which means we've got to go this way by 165 degrees. So don't stress too much about that. I'll go into more detail about that in a second. Right. Let's recap this for a second. I told you this is hard. I told you it's difficult. Right. Let's look at the start of the problem. Z squared equals 16 cis 30. We know for a fact that we could add an infinite number of 360 loops and it'd still be this same number. So we substitute in, or we add in a 360n. Make it a little bit bigger. It's kind of hard to get it all on screen. Okay. So we add in a 360n. We then use De Moivre's theorem, or we then basically undo this to the power of 2 by square rooting. And we use De Moivre's theorem where this square root happens to the 16, which gives us 4. But this square root, when it happens to this, it actually becomes a times by a half. Right? So this times by a half is times by a half to 30 makes 15. Times by a half to 360 makes 180. So we've got z equals 4 cis 15 plus 180n. And now we're going to use values of n to produce our loops. Right? So if n is 0, which is no loops, just the first number, then we get 4 cis 15. And then if n is 1, we do it all, we get 4 cis, or we actually end up with 4 cis 195. I converted that 195 into a better version, which is going negative 165. But this conversion here, I don't want you to stress about too much. If you understand everything up to this 195, don't worry. I'm gonna do another problem and we'll explore it in more depth. We need to get this before I look at the next problem. Questions, queries, thoughts? If you're a little bit lost, don't panic. How many times do we have to do it? Good question, right? We've got a z squared, right? What does the fundamental theorem of algebra say if we have z squared? If we have z squared, it means we have two answers. Hamza's right. If we have a z squared, it means we have two answers, so we're going to do it twice. But watch what happens if we do n equals 2, which is what Miraji's asking me to do, but I was going to do it anyway, trust me, right? Because the fundamental theorem of algebra says that we can only have two answers, right? So if n equals 2, let's see what happens. Z equals 4 cis 15 plus, we've got 180 times n, I'll even write it out for you, 180 times 2. Z equals 4 cis 15 plus 360. Okay. Z equals 4 cis, this is 375. But you could also think about it, bigger. You could also think about it as, look, we've got 15 plus one whole loop anyway, right? Which is just going to become positive 15 again. Let's draw the diagram over here. 15 plus 360, or sorry, 15, we've done 15, and from here we do a 360 and we end up here. And look, it's the same answer as the first one, as n equals 0. This is the same as this. 4 cis 15. Which is n equals 0 anyway. And if we did n equals 3, we'll bounce to n equals 1. We'll get this answer. And if we do n equals 4, we go back to n equals 0 and 5. So you could do it an infinite number of times, but you'll just be getting the same two answers. Maths is magic. It's beautiful, logical magic. Right? And so Hamza says, but somehow if it was z to the 3, you'd get 3 answers. He's exactly right. So let's do that now. Right? Example 2. But do we agree that we can only get 2 answers out of this? Are we happy with that? Hopefully, has that answered your question, Kate and Hannah and stuff? I kind of get it. Good. Kind of getting it at this stage is perfectly fine. Right? Let's look at a whole nother problem. Because I've been spending hours doing this, right? And I've just been practicing and doing heaps of problems, and I've gotten better because I'm doing lots of problems. Well, let's put it here. Example 2. Look, there's my notes for example 1. Move that to the side, get out my notes for example 2. Okay. So we've got z to the 3. I'll try write a bit bigger actually, so I don't have to keep zooming. Z to the 3 equals, that's really big actually, root 2 cis 45. Okay. So, let's have a little look at this. The first thing we're going to do is we're going to state what this could be written as with a bunch of loops. Z to the 3 equals root 2 cis 45 plus 360 n. Okay, I'm expressing this number as an infinite number of loops on itself. Now we're going to use de Moivre's theorem, or now we're just going to use algebra to undo this first. 45 plus 360 n, all to the third. Remember the opposite of to the power of 3 is to the third. Okay, and we're going to do bit by bit. Z equals, so the root 2, if you need your calculator, go for it. I happily would. You could do a couple things. I'm going to go like this, root 2 all to the power of 1/3. We're taking the third root of it, right? It's going to be some ugly fraction. But if you know your power rules, you could write it out, but who cares? Let's just write it as a decimal, right? Because often in these questions you end up with decimals. And remember, this all becomes times. So I've replaced it, sorry. So 45 times by a third, which is divide by 3. So Maraji says 6 root 2, or the 6th root of 2. So you could write it like this if you wanted. I'll write it in the next line of working. Right? 15. But I think having the decimals in there is good, Maraji, because often there's decimals. I've noticed that there's lots of decimal answers for these. Plus 120n. Or is that just because I don't know my roots very well? Tell me if you're happy so far. So Maraji is saying you could also write this like this. The 6th root of 2 cis 15 plus 120 n. So far so good. Right? Once we've got this, we then lay out n of 1, or sorry, n of 0, n of 1, n of 2, and go like that. Right? Now, let's have a little looky at this. If n equals 0, then what are we going to get? 6 root 2, oh sorry, z equals 6th root, I'm writing a bit bigger here, cis 15, right? That's always going to be your first one. And if n equals 1, Maraji, don't spoil it, I'm going to get there, trust me. Okay, I know what you're thinking right now. I'll get there. 15 plus 120 of 135. And I do a little check. Is this over 180? No, we're happy so far. So we're good, right? I know that's not going to go and become a negative. Mr. Maraji, trust me fully. Good. Okay, I'm going to scroll down a little bit further. I can probably fit it in here. If n equals 2, then z equals the 6th root of 2. Oh, I kind of want this. I want to drop this down. If n equals 2, then z would equal the 6th root of 2 cis 15 plus 120 times 2. So 15 times 120 times 2, which is 240, which makes them 235. No, 255. Is that right? And we've got 3 answers, because we got 3, but 255 is past 180, so we should fix this up, right? And go, think about this, this is 255 around here somewhere, right? We go 105 in the other direction. Okay. Nah, nothing can rival that, man. 225. It's not 225. It's definitely not 225. 255. Because 120 times 2 is 240. So are we happy with how I've got these three solutions so far? Hannah's happy. Are we happy with this? Right? We know that we're going to have three solutions. We know we're going to have three solutions because of this. Oh, I raised the diagram already. Sorry, boss. But I'll get there. I'll get there. We know we're going to have three solutions, and we've got n equals 1, sorry, n equals 0, n equals 1, n equals 2 produce our three solutions. Right? But this process here, I'm going to write here, is annoying. Right? And in the last two questions, it's happened both times, where we've produced a number higher than 180 for the angle, and we've had to go, 360 minus that thing, and then think about it, or draw the diagram and think about it. Right? That's annoying. Is there a smarter way? Is there a smarter way in which we could do this? To make this process not even happen? Is there a smarter way that someone can think about it? Surely. Right? If only. It's always the same. I'm trying to challenge you guys to this one now. Right? Right? If only there was a smarter way. Right? So have a think about this now. Right? We know that if we got n equals 0, n equals 1, n equals 2. Then if we did n equals 3, we'd come back to 0, and so on and so forth. Right? So, Fat Pikachu says, why is it minus 105, not 105? Because if you look at this 255, I'll underline it in blue. If you look at this 255, 255 goes around like this, and so the actual angle is minus 105. The minus means the direction. We rotate the other way. Okay? So, very quickly. Right, back to this. This thing here is annoying, this process. If only there was a better way. Let's have a think about our understanding of n. Right? So we had n equals 0, n equals 1, n equals 2. Let me try something here. What about n equals minus 1? I'm going to fill up my drink. You're going to follow through with n equals minus 1 and tell me what you get as an answer. So follow through with n equals minus 1. I'll make sure you can see it's 120n. Okay. I'll fill up my drink. Follow through with n equals minus 1, please, and tell me your solution for z. Right. Kate's happy. Rishi's happy. So if we have a look at this, Hamza focus. Hannah's got the same answer. Very quickly, because I know you've already done it. 6 root 2 cis 15. Oopsies. It'll be minus 120. Won't it? Right? 15 minus 120. Oh my goodness gracious. Minus 105. You see that there? Oh look, my camera froze. What a time for my camera to break. Oh, I gotta unplug it, replug it. My camera breaks sometimes, so you guys know that. There we go. Sorry, that would have been scary. Right. So, are you happy with what I've done here? When we use n equals minus 1, we get that answer. Right? This answer, oopsies, is the same as this answer. Okay? So, Kate's very happy. We're all very happy. Now, here's a fact, and this is always the case. The fact is, the solutions, let me scroll so it doesn't, solutions always, I don't know the right word, but I'm going to say like pivot, but I'm not going to write it, but always are around 0. Or let's say n equals 0. They always pivot around n equals 0. Or they reflect at n equals 0. What I'm trying to say is, e.g., if you have 3 solutions, you will always have n equals minus 1, n equals 0, and n equals 1. If you had 5 solutions, you will always have n equals minus 2, n equals minus 1, n equals 0, n equals 1, n equals 2. I know that's getting really, really small. But it will always pivot around n equals 0. Right? Are we focused? Are we on task, guys? Think about this. I mean, it's kind of parabolic in theory, but not really. It's just the way that the loops work. Right? Which means, like you can see here, for 3 solutions and 5 solutions, when you're pivoting around 0, it's really nice, right? You get 1 on each side. But when you get like 4 solutions, you have definitely 3, minus 1, 0, and 1. But the 4th one, you don't really know whether it's at minus 2 or 1. Or sorry, or positive 2. Do you get what I'm saying? Please tell me you're following. Yeah, this is basically your first lesson of calc, Krish. Kate's with me, right? Kate's following. So far, we're so good. So what we're going to do is we're going to look at question 3. But it'll be the same answer. It doesn't matter, right? It does matter, because what will happen is I'll prove it to you. But what will happen is if you do a positive 2, you'll find one of your previous solutions. What I'm trying to say is, if you, let's say you did n equals 2, and that's not the right one, you will end up finding one of these ones. So surely in the end we get an odd number. That's good thinking, Hamza, and typically it is. So you should be prepared for 3, but sometimes it's 4. Mr. Maraji will know better than myself. I think it kind of ranges. Let's do another example, keep ourselves on track. Right? Example 3. Right, let's look at this. Z to the 4, oopsies, equals 10 cis 60. How long says this? I told you it's going to be a little bit longer than normal, but we'll do probably this one, and maybe this one or this one, and then that'll be it. Or maybe just one more. Yep, Miss Murray said make you guys do it. Start this one, please. Right? You should start it. I'm going to go much faster this time. But can you start it? Make sure you're on board. It's the exact same process. There's one thing I always forget to do, which I'll tell you when I get to it. But start it now. I'll have a drink. But this lesson is going for a bit longer than normal, so we'll call it soon. Mr. Maraji, if you're listening, can you send me the answers, or can you work through, if you get time, sometime today, work through these answers and send them to me? I've done the first two, but the next ones I'm kind of struggling with. This one I can kind of do, I think. I think I can do them, but I don't know if I'm doing them the easiest way, is what I'm trying to say. So that's in your complex roots worksheet. Can you please do that and send it to me, please, sir? Thank you. Right, let's do example 3 now. We're going to start it. So the first thing we say is, I can also write 10 cis 60 as 60 plus 360 n. Okay. Now, if this is true, then I can then undo my power. 10 cis 60 plus 360 n all to the quarter, which means we're going to do the fourth root of 10, which I don't think is anything nice, so we'll just leave it like that. 60 divided by 4 is 15. 360 divided by 4 is 90. So far so good. Okay. Oh, I haven't got my notes for example 3. Here we go. Now we're going to look at a whole bunch of different values for n. I'm going to start with, let's start with n equals 0, right? We always end up with z equals 4th root of 10 cis 15. That's the easy one. Okay. With n equals 1, we get z equals 4th root 10 cis 15 plus 90, which equals 4 root 10 cis, what's this, 105. So far so good. And now I want to think about something here. Just imagine this, right? Every time we're adding another n in the positive direction, we're adding another 90 degrees. Right? That's what this whole thing is saying. Every time I add another n, so when we went from 0, we went to 1, we added another 90. And if we went to n equals 2, we would add another 90 onto this. So if I thought about this before I even do it, if I added another 90 onto this, I would have 195, wouldn't I? Which I already know is over my 180 degrees, which is like that, right? So I already know it's over that. So I can already think to myself, it's not going to be n equals 2 as my fourth solution. Which means it's going to be n equals minus 2. Right? But I also already know that I've done n equals 0, n equals 1. I know we have to pivot around 1, so I know these three are for sure true. So let me do my n equals minus 1 first. Z equals 4 root 10 cis 15 minus 90, which is 4 root 10 cis, I need a calculator, 15 minus 90 minus 75. And I can also think about this, right? I keep going down 90 as I'm going down in n. So if I minus 90 onto this, I know I'm not going to get over 180 in the other direction either. So I can also think that way if you wanted to. N equals minus 2 would produce z equals 4 root 10 cis minus 165. And those are our four answers. Cis 15, cis 105, cis negative 75, and cis minus 165. And that's gotten significantly easier from when we first tried it, isn't it? Look, Kate's getting approval. Kate's done well. So far so good. So example 4 and 5 kind of go up another step in terms of difficulty. Or not in terms of difficulty, but needing more working. Doesn't matter if you don't get the fourth root of 10. What did you do? Did you write it like this? 10 to the power of... What is the answer? 1.77. That's fine as well. . Better send you to a nerd. Good, good, good. Um, does it matter if we get the 4 through to 10? If you wrote this decimal instead of that, that's 100% fine. Yeah, that's fine. Hannah, can you write 4 through to 10 in the exam? For sure. It's the same thing. It's like saying, can I write 0.5 instead of a half? You can. Why doesn't n equals 2 work? Let's do n equals 2, eh? I'll do it out to the side here. And let's see what, now I'm saying is n equals 2 will produce one of these. And Hannah had a question from ages ago that won't that just produce the correct one anyway? Well, let's have a look very, very quickly. And if you're okay with this, you should start the question Mr. Maraja just posted in the chat if you want. It would be 15 plus 180, which is z equals 4 root 10 cis 195, which means it's 360 minus 195 minus 165, right? So in this case, it does work, but we have to do that conversion, don't we? Yeah, it's only m. You with me there, Hamza? So n being 2 does work per se, but it just produces a slight more step. Cool. And sometimes maybe I'm wrong, but sometimes I feel like this produces the other ones, but maybe I'm wrong. Right. Miss Murray, do you want us to do, I'll leave these two for you guys maybe, and for homework, and this is extra homework as well, but these two are probably more important. And we'll do the one you said in there. I haven't done it before, so I love it doing maths live, right? So let's see. The question was z to the, I'll write it in blue. Z to the 3 equals minus 1 minus root 3i. Right, you guys can start it. Right, it's gone 12 o'clock, so we've done an hour. I'm going to do one more question. Mr. Raji, which one do you think I should do? This one, or this one? Yep, what's the first step? I'm expecting some answers in chat. So this is another layer. There's another layer to this problem, to everything else. And the layer is at the very start. Diashock size correct. Tina is correct. Right? We cannot do anything until we convert it to polar form. Yeah, so I'll let you guys do 4 and 5 for homework. And should I go through this one, or are you saying leave this for homework too? Maybe we'll leave all 3 as homework. And I've done my hour dash. Yeah, alright. So this is your homework here. Write this down if you're in the stream. This is a stream only piece of homework because the people that are not in the stream won't really see this. But I might add it to this list of questions anyway. So smash this one. And we can pick it up from here tomorrow. Good idea. So I can start with this problem tomorrow just to refresh us. And then if you really want to get ahead, you can start looking at question sheet 17, which is what we're going to look at tomorrow. Okay, so just a heads up, guys. Tomorrow we'll do a ask your question, Kate. I'll just talk for a second, but I'll answer it, or Margie will too. Firstly, tomorrow we'll carry on with this and look at letter questions with this concept. Right? It's not really too much more difficult, but now that we've learnt it, we can apply it to harder stuff. Secondly, remember the assignments, right? Please keep tracking away at them. Oh, secondly, all of this is uploaded onto my Google Classroom under Moivre's Theorem. Right, 1, 2, 3. And what I wanted to say was, the other thing is to just make sure you're looking at the assignment and trucking away with that, right? There's definitely De Moivre's theorem questions in the assignment, 100%. Right, so follow this post I've done here. But there's definitely De Moivre's theorem in the assignment, so make sure you do those. Kate's question, I might need a bit of help with that one, Maraji. I feel like there is, but maybe I don't know who you're answering, Maraji. So, Kate's question, you know how -2 and 2 are the same? Is there sometimes when they are different to each other? I'm gonna say no, even though I swear I did a question the other day where it was, but I can't find my notes on it. So, I don't exactly know. Mr. Maraji, what do you think? I see you say no, but I don't know if you're answering Rishi's question or Kate's question. I'm sure he's typing something. So let's wait for an answer from... Either they'll be the same. Okay. So, they're always the same. Right? But you just... Well, you could use... you can't use both because they produce the same answer. But you could use either if you wanted. Hamza, you're getting confused here. Here. When we did -2 and 2, -2 produced this answer, 2 produced this answer. These are the same things. Right? But when we used our +2, we had to do the extra step of converting from 195 to -165. But if we just used our logic and used -2, we don't have to do that extra step. Look how quick this happens. Boom. Versus these 3 steps here. So yeah, exactly what Kate's saying. One is more complicated, but the correct answers are n equals 0, n equals 1, n equals -1, and either of these two, as long as you do the conversion. So the actual answers are cis 15, cis 105, cis -75, and cis -165. It just means that 2 produces the same solution as -2. Remember, n is not the solution. These are the solutions for z. N is the rotation. So these are our answers. I'll even underline those properly. So my answers for, because the question is, these are our answers. So even to wrap your head around this, but the way I think about this, right, is that we're trying to find z to the 4. Sorry, z to the 4th power, right? Or we're saying that the 4th root of this could be this, 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 or this. These 4 answers. So the 4th root of 10 cis 60, the 4th root of this, what times itself 4 times creates this number, is both this and this and this and this. The 4th root of all of those, I'm thinking about this wrong. So remember, these are our answers. Sorry, I just read in chat. These are our answers here, right? 1, 2, 3, and 4. Not the n. The n is just related to how many rotations we're doing. Okay? Right, you've got a little bit of homework to do. Here's your question here. And these 2 here. There's only, like, the maths is almost identical. There's just, for this one, there's an extra step at the start, which is the same as for this one here. And at the bottom, this one, there's an extra step at the start and an extra step at the end. Right, this one is an unnecessarily long one, but I want you to do it anyway. If you do this question, 4 and 5, then don't stress too much about these. Okay, these are just like more work. If you're happy with everything we've done, you probably don't need to do this homework. This homework is extra questions for extra thought. Okay? Die well, no worries. I don't know who you are, but thanks, dude. Thanks for the sub also. Number 1 sub. Best sub in the chat. We recommend this channel on my exams and pull a Hamza. Right? Mr. Murad is happy. So if we're all happy, that's good. Tomorrow we'll be doing a live stream. What I was going to say is that tomorrow we're going to live stream a little bit more Moivre's Theorem, which means we'll do one more stream on, tomorrow's Tuesday, on Wednesday, I think. Okay, and then I'm definitely done. Then I'm on holiday. Okay, so we'll do a stream on Wednesday to go over locus, right? Which I need to learn how to do, right? You're sub to me mentally. I appreciate it, Krish. I appreciate it. Right, big brains. We've all got big brains. Please complete this. Mr. Maraji, please send me the answers to this so that I can make worked answers if you have them, please. Or just answers and I can figure them out. But the way I've been doing it seems really, especially these ones, I'll quickly ask you if I'm doing it right. The way I'm doing these ones is turning them into like I'm substituting like a let m equal this part here and then go from there. And for this one I've turned it into a quadratic, but I don't know if those are helpful. They seem like a lot of work, but maybe that's just what excellence is like in calculus. Right, y'all, so many big brains. We all have big brains. I agree, Kate. Miss Radio says, yup. Is that a yup to I'm doing it correctly or yup to you'll send me the answers? Because I just don't want to overcomplicate these questions here. And tomorrow we're probably just going to go over like this one, and maybe like 1 or 2 of these E1s. Oh, doing it correctly. Okay, cool. Okay, don't worry about these first 2, sir. Just send me the... can you do the worked answers for these 3, please? And send it to me. Just take a photo and send it. And then I can make sure I understand it properly too. That'll be amazing. Please. Thank you, thank you, thank you. Right, we're done, guys. Well done. Tune in tomorrow. Please spread the word to everyone. It's a little bit more quiet than usual. So please, please, please tell everyone. There's a lot of lurkers today though as well. Right? Thanks. The lurkers really help as well. Thank you very much for tuning in, guys. Really appreciate it. Even if you came late. Love it. What are ways I can contact you? Just send me an email, Tina. tyler.benson@migs.school.nz. I might not write it down, but yeah, tyler.benson@migs.school.nz. Send me an email. I think you've emailed me before, Tina, even. Hamza, you're dreaming. Cool, we're happy. I'll post the answers on Google Classroom shortly over the next couple of days. But more importantly, please tackle this example 4 and 5. Just 3 questions. You could do them now, it'll take you 15 minutes. Cool beans. Thank you so much for tuning in, guys. Really appreciate it. I loved going through calc. It's really fun. I spent ages going over how to explain this, so hopefully it made a lot of sense to you guys. You've already done 3, just 4 and 5 and this one, the special one. Okie dokie. Looks like the longest sign out ever. Right, I'm done. See you guys later.